Bob, we're ready to get started. Oh, and we are on the air. So I will call to order the Tuesday, December 13th, 2022 meeting of the Elementary School Building Committee 2. Quick rundown of our agenda. We will have our opportunity for public comment. Then we'll move into new business. We have some meeting minutes and invoices to approve. We'll have a brief recap of the school committee discussion on the educational plan, as well as any modifications that were made to the PDP report prior to submission. We'll get a brief update on interactions with the MSBA. We will briefly discuss the preparations for an update we've been asked to give at the select board next Tuesday, December 20th. We'll then review the proposed mechanical systems options and cost comparisons for alternative systems. So getting into a little bit of some of those design considerations that we have for the building, as well as sustainability strategies for the building. And then the last two items are kind of our standing ones, which is an update on where we are in the design options and reviews to the updated meeting schedule. And we will try to wrap up as close to 8 o'clock as possible, or if like last meeting, maybe even earlier.
Maybe.
So with that, I will open up the opportunity for public comment, and unless that's what Dan and Bob are here for, and other than just not enough chairs at the table, I'm assuming we don't have anyone in the building for public comment, but we'll have the opportunity to open it up later if anyone arrives. So next we have meeting minutes to approve. We have the minutes from the December 7th, 2022 meeting. The draft has been included in the packet. Are there any questions or edits to the meeting minutes? Hearing none, I will look for a motion to approve the meeting minutes of December 7th, 2022.
I move the minutes of December 7th, 2022 as written, sir.
Okay, motion by Mike. Is there a second?
Second.
Second by Jagroot. We have no voting members participating remotely, so we can vote normally. All those in favor of the minutes? Aye.
Aye.
Any opposed? And it passes unanimously 5-0
Thank
for
you.
Chris's benefit. We should all, like, voting members should have to wear the same color shirt so you can pick us
We'll get
out.
you special
That would
hats
help.
every-
Yeah, there you go. Special hats. We work on those for the new year. Next, we have some bills to pay. So, and I've got them somewhere here. I swear I had them. Oh yeah, there it is. Okay, so we have 3 total invoices. One for Compass Project Management / Vertex as the OPM for the feasibility study in the amount of $9,807. And then we have 2 for Perkins Eastman for the feasibility study as well as other work. The first is in the amount of $52,760. The second is in the amount of $24,250. All of the invoices and backup materials were in your packet. Any questions regarding these invoices?
So
Jeff looks
can-
like he's going to say something.
Can you go over the dollar values there again?
Yeah, so I have $9,807 for the first and only Compass,
Yep.
one that's in there. $52,760 for the first Perkins Eastman, and $24,250 for the second one. Total value of those two is $77,010.
Are those last months, or is that?
No, the total value is $86,817.
Total value of all of them is, I was totaling the
Just
the
Perkins Eastman.
Yeah,
The Perkins Eastman I have is 77,010.
that's the total of the 2 Perkins Eastman ones.
Okay.
So the $52,760 and the $24,250 adds up to $77,10. I'm almost positive.
Sheet out for you for a second. Yes, so it's listed as 2 invoices
Okay.
in the
Mary's
account,
got
but
it.
there's one physical invoice, which is 77.
Okay, I see, that's probably, is it, I mean, I didn't know if that was a breakout between the
It's
time
It's a
frame or-
breakout between the
Combines.
2 phases.
The 2
So
phases, okay.
Yes.
It's a
Yeah.
for
Part of it,
clarification's sake, we're because of the MSBA's coding system, the system-wide study is coded separately because
That's what I figured it would, yeah.
the MSBA doesn't participate in that aspect of the project. So you have an invoice to the MSBA that they participate in, and a second invoice to Perkins Eastman that the MSBA doesn't participate. That's the distinction between the two.
Okay. And is there any do we care how we do the motion, or?
Does it matter to you, because you're
Doesn't matter to me.
Okay.
just gonna do a ledger adjustment, right? Or-
Yes.
Yeah, okay. And no.
All right, so then, if there are no questions, I would seek approval of the invoices to Compass Project Management and Perkins Eastman. The total amount of invoices to both parties is $86,817 in accordance with what's in the meeting packet.
So moved.
Motion by Bill, second by Mike. All those in favor? Aye.
Aye.
Any opposed? Okay, passes unanimously.
I do have a question on the follow-up material.
Yeah.
On page 5 of 13, and just for understanding, I'll wait till someone from those groups can pull up. It's breaking down, it's under billing phase.
Which page?
Shows feasibility, you can even look on my page 5 of 13.
Yeah.
Shows feasibility study, 263,000, schematic design, 262. So it's north of 500,000 allotted for those two. And then it shows a district-wide study of 41.5. Is that the total amount that's been approved, that it's been allocated? Or is,
There's the consultant fees is another line item below that that's not reflected in that. So the page before, or page 4 tries to show the total allocation. So the total dollars committed to Perkins to date is the $627,000 on the page prior to that.
well, I'll ask more specifically. The district-wide study was an $80,000 allotment.
So that, the only portion applied to Perkins is the $41,500 from that $80,000
Okay.
allotment.
All right, so there's available money for other
In the
parts of
district-wide,
that
yes.
study? Okay, thank you.
Yeah, and just to clarify for anybody watching home, so that's the difference between the amount of money that was appropriated at town meeting and the amount of money that's applicable to what the work that Perkins is doing. There's a $39,000 kind of ish left over.
Thank you.
Correct.
Okay. So next up is recap the discussion from school committee meeting on the educational plan.
We actually vote on that.
The invoice?
Yeah.
We did.
Okay. Sorry, I was catching up with the
It was still 5-0, but if we have any other votes tonight, you gotta keep an eye, because we just got a 6th voting member.
Okay.
Gonna throw everything off, I know.
She came without her hat.
I should have asked this ahead of time. Who am I going to for the recap on the school committee discussion on the,
So that took place last Thursday on the 8th, and it was hardly a discussion. I mean, I think that they were very eager to approve the educational plan. They thanked us for our work, and, yeah.
anything to add on that one?
I wasn't there.
Okay.
I was away
So
at
probably
work
not
last week.
So, yeah, so the output is the
Yeah.
educational plan was approved to go into the submission, which went into the MSBA on Friday, which was the missing, the remaining piece that needed to be added in on the Friday submission, so that made it in.
And a quick reminder that the education plan at this stage is somewhat of a draft education plan that we'll be going back and forth with the MSBA on as we zero in on our final selected option.
That's correct, the MSBA will provide comments back and
And we welcome them.
You count on it.
Okay. And then next up is any modifications that occurred to the PDP report between when this group voted to approve it and when it was submitted. I know there's one item that you and I just discussed that which probably.
There's two items, yeah, and that reminds me, I didn't resend you it. So we had, we got an updated cost from AM Fogarty, so we had two estimates. We presented you guys the draft. At the time, Dan and I had sent some comments back on the lower of the two estimates to quantify a couple of things that we saw were missing. So we got a revised version to Fogarty, and I will submit that to you guys. I meant to include it in this week's packet for record, but it closed the gap between the two estimates. So we still came in below the higher estimate, but was closing the gap and really starting to see things a little similarly.
Okay.
And so I did include that in the submission to the state, and I will
Great.
send that to you guys for record.
Thanks.
And then the other item is that they responded back that we need to modify the signature on the local actions letter. They had inquired if the chair board selectman was actually the CEO's designee versus the town manager. I had the town manager sign it, so we'll need to collect an additional signature on that other document, which is the local actions letter.
And just for committee's sake, as we discussed before the meeting, Jeff's gonna get me that, a form to sign, and then I'll reach out to the select board chair and have her sign it.
Thank you.
Anything else under updates from the MSBA?
No, nothing, they didn't note anything was missing from the submission, which is always a good time. And so we're just waiting to hear back from them and their comments, which we expect back in a couple of weeks. They take usually 3 weeks, so I'm not sure whether they'll get us something before or after the break, the holidays, but somewhere in that neck of the woods.
Okay, thank you. Any questions on any of those 3 items? So as I mentioned, we have been invited on next Tuesday, December 20th, to provide an update to the select board on the project. This invitation came from the town manager in a meeting that Mike and I had with him a few weeks ago. I don't believe, although I'll ask Shadul if there's anything specific, but from what Norman said, there's nothing in particular other than just an opportunity to update the select board on where we are, what steps sort of have occurred at a high level. I know that many of them have been following the process, but also it's always nice to give us another opportunity to talk about the project in public.
Yep.
So, anything
I
else?
think that's pretty much. We want to probably get an kind of understanding of where things are and what are the immediate plans. And one thing you may focus on a little bit, what are the upcoming decision points and what is our communication plan? There's some interest in that.
Okay, yep, I think that will, and I think it's really well timed to talk about the upcoming decision points because, again, I think that's something that we want to be talking about as often as possible in public because we know there are a lot of them that are gonna come very quickly in the new year, and we're entering a time when people probably aren't paying as much attention to those things, so we don't want them to be surprised come January. I am planning to attend and present. We can discuss, you know, who else would like to attend, in whether or not we need to post that just as a meeting in case we're gonna have 4 or 5 people there, and then and we can discuss what other resources are needed. But I think given that it's a fairly kind of straightforward time frame, decision, schedule, update, you know, hopefully we can do it with as many sort of volunteer committee members and not necessarily impress upon the professional staff as much as we don't need to, because I know that all of you come out to these meetings a lot late at night, and this one doesn't seem like it's gonna be that big a, you know, I don't expect to be sort of on the hot seat for this one. So we can, you know, discuss virtually as we go on, what the content is, and then but wanted to make sure everybody was aware of that. Okay, so we're gonna move now into the review, proposed mechanical system options and comparison comparison costs for alternative systems. But if there's no objection from the committee, I did notice 2 people came in during the meeting. Were either of you hoping to provide public comment at this meeting, or are you just here for?
She's with us.
Oh, okay,
No place else to go.
okay.
Yeah.
I had a general question, but it might not be the appropriate time. But it had to do with, and it could already, my apologies if I haven't been paying attention, but my name is Jane Moran, 70 East Main Street. I'm speaking as an individual citizen, and I'm just curious about the growth of the school system, and if there are plans in place to maybe put in place structures, infrastructure for a second or third story buildings for some of these buildings that you're planning, in that the growth of the town is so fast and furious, it doesn't seem to be letting up. So one time when I went to the Marathon School building, I was too late. They said, well, it's too late, the time has passed. So, you know, you're too late to the game. And I might be too late to the game now, but it's just a thought. Has this school committee, elementary school committee, given thought to planning for the future, and could there be plans for going up in any of the buildings say, future gym space or cafeteria space in the properties that you're looking at, even though you may not build it today? But could there be expansion plans for later? Just a thought. You know,
So, I'll take a first shot at it and then invite anyone else up here to provide feedback. I mean, first and foremost, well, thank you for your question, and I'm not sure how much the microphones picked up for those at home, but the question was really around thinking about potential future expansion, as we know Hopkinton is continuing to grow, as we think about design decisions for the new elementary school. Is that a fair recap? So first of all, you're not in any way too late to this process. We have not yet begun we've begun, but we have the design discussions and decisions are at a very early stage. I would also add that one of both our criteria and the MSBA's criteria in looking at potential sites and potential design options is allowing for future expansion. So as I'm sure you know, with the Marathon School, we built it in such a way that while we haven't gone vertically, we built it in a way on the site that we've been able to add on several classrooms as we've seen more expansion in the town than we probably anticipated. That's a consideration for us as well, is making sure that we have sufficient room in these sites to expand in the future. In terms of vertical, we have also discussed 3-story designs for these schools. In particular, one of the decisions that's going to be coming down in January is whether or not this new building is going to be a 2nd and 3rd grade replacement or a 2nd, 3rd, and 4th grade school that will help us will help the district move around some of the growth challenges. And most of the potential designs that we've looked at for a 2, 3, 4 school are in fact 3-floor schools. So that is absolutely something that is under consideration. In terms of, I will just say, in terms of this committee's purview, it's really only that new building that we're building. So for the other schools that exist in town, it would be the district or the school committee that you'd want to also direct those questions to, because our purview is pretty narrow in terms of just this one singular project. Does anyone else want to add anything to that? Did I miss anything?
I can speak kind of outside of the
That'd be
ESBC
great.
for the other buildings. So what we are also doing with the school committee, along with the ESBC, is looking at our other buildings that already exist. And trying to plan for that growth, looking out at our enrollment projections to 2031, 2032. So there is a need for expansion in all buildings. You would not be able to add a story to the existing building from a structural engineering standpoint, but you would be able to add an addition that you could do as many stories, but you wouldn't be able to just pop up a story from an engineering standpoint. But we are looking at that and beginning presentations of what the needs are in each of the buildings will begin to the school committee in January.
Yeah, and that's another great opportunity for us to plug the schedule, right? So in January, there are going to be discussions at the school committee level around future grade configuration and the needs in all buildings within the district and potential plans to expand to drive growth, which will feed directly into the decision about what the grade configuration will be for the new or renovated Elmwood School that will then go to the ESBC, that will then, towards the end of January, maybe early February, that will then have us driving our decision around what is the preferred option that we're going to pursue for the new school. So I want to practice saying that out loud as much as possible in the next meeting. Thank you.
Thank you.
Okay, so mechanical systems options.
Yeah, so I'm going to just set the table and we'll introduce our two partners here. We have one remotely, which is Heather. I don't know if she's still with us or if
We had one remotely.
lost her.
I'm here.
Screen
Can you hear me?
She can hear us.
Can you hear me? I'm here.
Okay.
She's not on the TV anymore.
I'm working on it.
Okay,
Yeah.
cool.
And then,
Thank
Dan-
you.
Dan from Perkins and Jesse Farber from the Mechanical Design. So today, you know, we had talked about sustainability back when it was just the OPM on board in May, and then again in the fall in a community forum. So I've asked the design team to, you know, start to put that into the context of the project now. At that point, it was more about principles and practices. So now we're going to start to talk about the goals and context around our project. We'll discuss on process a little bit and the various systems that are out there for you guys to consider. And then setting the roadmap for the financials. We're not going to get into financials today because we're looking to understand the goals and desires of the committee. We will come back with a cost comparison about all electric, geothermal, plus base gas systems. I'm going to turn it over to the design team to make that presentation, and they have a slideshow as well. So,
Terrific. We do have one, if anybody wants to gather around here, or if we can project it, that would be terrific.
I don't-
too. I don't know.
He's
We're
trying,
working on it.
yeah.
He's working on it.
Okay.
And the slide presentation is the one that we all received today in your,
You received in a draft form. It's a
draft
little
form,
bit-
yeah.
probably
I don't know
tweaked
if
a
there
little
may be
bit.
some
It's a little
stuff.
tweaked,
But
but
it's
it's-
effectively the
Close
same.
enough if we-
It's
if we
effectively
have it
the
up here.
same
Okay.
thing, yes.
And Heather, you were going to kick us off. I don't know if we can hear you or not.
Can you hear me?
yes.
Way over there.
Yeah, we'll listen very. You're off in the corner. Go right ahead, though, Heather. We can hear you.
Okay. Yeah, so thanks for the introduction. Sorry I can't be there with you today. I'm stuck at home with some sick kiddos, but we have a lot of people in the room, so I'm going to let them do the majority of the talking. But yeah, today I just wanted to take the opportunity to revisit some of the initial conversations that we had around sustainability, revisit the priorities that we heard coming out of the community and faculty forums that we had done from a sustainability perspective. And then use that to discuss what our process is for system selection, as Jeff was discussing. So we, you know, coming out of the recent estimate and moving towards the next one, we're setting up a process that we're going to outline for you, which will allow us to look at variables in tandem. So when we're selecting a mechanical system, there's a lot of different variables that we like to look at. And so we're going to discuss some of those priorities with you today, get a little bit more input and feedback on that. And as we go for the next month or so, we're going to be looking at those variables and looking at things like how we're sizing our envelope in relation to our system choices to optimize both for performance, but as well as optimize for cost. So we're going to outline what that process looks like. We're going to talk through some different system choices, some basic pros and cons without getting too into the weeds. We'll talk about some local case study projects that are employing these different systems. And then we'll kind of end on a next steps conversation and what we're going to report back to you on in January, looking more into detail around some of the kind of metrics with which we can study these systems.
Okay.
So with that, I'll pass it over to Dan and Jess. I'm not sure if you're sharing your screen. I can't see it, but
Not yet.
No, we're working on that. You do have your presentation, right?
Yep.
So I see there are a lot of devices here. So I think that the first thing that Heather wanted to say was that you know, we're listening. We're listening to your priorities of the committee, of the teachers, and so forth. And one of the things that we are hearing really is that top priorities are energy and well-being in particular. And then how can those things be integrated into the design and be used as part of the educational community and process for discovery for the students, for the teachers, and so forth. So, you know, we're listening. It doesn't mean that, you know, the other things are not going to show up. We've been talking about sustainability. These are just some of the priorities within that umbrella. What we would like to do is just talk a little bit about the context of this. And so, you know, you can look at a global context, maybe a Commonwealth of Massachusetts context is a good place to start. And so the thought that the Commonwealth is trying to move towards carbon neutrality in terms of not using fossil fuels overall and addressing climate change in that way. The roadmap for decarbonization that the state is following and that the communities of the Commonwealth are following, really there are four key strategies that are shared here. Two of them are directly related to our sort of vertical development. How do we do buildings, and then how do we connect them? So how do we how do we address climate through buildings? We try to wean them from fossil fuels, make them all electric, and then we need to green the grid. We need to make that less dependent on fossil fuel. So that's a key. The goal is to do all of that by 2050. That used to seem really far away. It's not so much anymore. It's within the lifespan, easily, of the building that you are guiding. So that's important to know and to think about. You know, getting there, again, this is just another way of looking at how we're getting there, and this is to say that buildings are a very big part of that, major user of electricity, and so we need to be able to think about how we're decarbonizing. Can I?
No, I'm just saying, do you want me to project your draft? I have your draft.
If it can be projected,
That would be helpful.
we're connected, but it doesn't seem to be working, so.
Bob, will it work if I do it, or is it a?
Your Apple? It'd be close enough.
Or can we hardwire into one of the TVs, or
Yeah, I mean,
not with that wire, a different wire?
I could just start pushing buttons and see what happens. He's afraid to mess with it.
It says I'm on, Bob. It says, my computer says I'm connected.
Yeah.
Do you guys usually use the wire for your meetings?
We always.
That'll be helpful.
It says no signal, so
Yeah.
it's part of getting on the same page, right?
Well, a page.
On a new page.
Signal.
Oh, here it goes.
That seems positive.
One step closer.
Like a watch tea kettle. Everyone waiting for it to boil.
I feel like I should make something up about what's on the screen, just like narrate that.
Slow horses is a great adventure.
Yeah. We should have saved all the easy business for a second.
Make for good watching with no black screen for much of the discussion.
So we need like an 8th grader here to figure it out. That's right.
Here we go. There we go.
Got it, Bob.
Did we disconnect the lady that was on there?
How's that?
Terrific.
Looks like the picture.
Basically, what this slide
Is this the slide you were
saying-
on?
I have no idea.
Oh,
Yes, yes,
It is now.
Thank you very much. I do appreciate it. Basically, this is saying that, this 2050 milestone is fast approaching, and then, if anything, we're not going fast enough towards that target. So we have to actually increase our aspirations in terms of how we can move towards that target. So Hopkinton, we wanted to sort of set the context a little bit for what some other communities in the area are doing in terms of helping to meet that target. And so, we've looked around a little bit, and what do we see? We see many communities that are looking at getting to net zero at 2050. That is the state target. They're declaring that they're on board to do that, but then understanding that there are some intermediate goals that they might do in order to help get their community towards that. So that might be getting 50% of the way by 2030. It might be getting all of their municipal buildings off of fossil fuel by a certain target. So there are ways of getting there, and it helps to know that the buildings that they're working on, whether they're new or renovations, that those are moving as part of that target. And there are only so many projects that they get to do in the next 27 years that can help move towards that target. This is an example that you have now of a community that is trying to do that, setting targets along the way, focusing on electrification of buildings, trying to disincentivize putting more fossil fuel systems into place, so not connecting to natural gas, trying to make sure that all new buildings are net zero energy, net zero emissions, and then going back into the more difficult nut to crack, which is the existing buildings, and how do you do that? You're very familiar with the challenges of that. So Heather was saying, I hope that you could hear her, that really what we're wanting to talk about a little bit is the process and the decision making that lies not so far ahead in terms of how do we get there. So one thing is that we need to balance cost and capital expenditure as well as operational. But what about the capital expenditure? One thing to know is that the cost of doing high efficiency buildings, very high efficiency buildings that get us towards net zero energy, is a small percentage. Sometimes it's 0, sometimes it's 1%, sometimes it's less. So the point is that it's not about adding 25% to the cost of the building, typical budget these days, which is another question entirely, but it's not that net zero energy or high efficiency buildings is the thing that's doubling budgets or something like that. So this is,
I did want to comment on that too. Partly that's the holistic look at the view of the building in terms of other codes are changing along with this. There are new energy codes which are requiring the insulation to get thicker. So in isolation, these components can be substantial costs, but when you look at the overall goals you're trying to achieve, that's why the percentages end up being lower on the scale. As recent as 5 years ago, they were saying it was 7-8%. But some of these other codes are causing the holistic look to be brought up at the same level, and why that percentage delta is dropping, from where it was even a few years ago.
yeah, it's an excellent point, Jeff. And this doesn't distinguish between why something was more or something was less. And sometimes a high-performance building. It goes along with wanting, who did we lose?
Lost our screen.
We have Heather over here on this.
Yeah, we got
screen,
Heather
if you
now, we
wanna
can
look
see
at
her at
Heather.
least, that's exciting.
You know, so it's sometimes just hard to distinguish what is causing a building to be more or less expensive. We have taken this integrated approach for quite a while. This is one example.
The next one would have went to why you've done it, yeah.
Let's see, so Boston Arts Academy, there's an example that basically says looking at high-performance building envelopes can actually downsize the cost of the mechanical systems. So don't tell Jess this, but what we're trying to do is get the money out of the mechanical systems into the building envelopes. And basically what that does is it makes the building envelope that is more resilient, more comfortable to be in, and has less maintenance overall. So in the case of the Boston Arts Academy, right over the right field fence at Fenway, we found that there was basically no difference in cost if you upgraded the building envelope and downsized the mechanical systems, except that when it went out to bid, the mechanical systems had greater escalation or inflation compared to the building envelope, and so there was actually more savings involved in making those decisions. So it actually was a less cost choice.
And sorry, just to be clear, when you're talking about cost, you're talking about upfront construction cost. We're not including any net operational savings ongoing.
Net operational savings, that all comes.
Okay, I just want to make
It's
sure we were
also-
all on the same page about what numbers we were talking about.
Thank
Okay.
you, and it's also not including, you know, incentives or rebates or anything like
Okay,
that.
thank you.
When you're talking about discomfort, does that take in both like a hot day and a cold day, like 12
Both of
months
them.
of the year?
Yeah, because both the extreme cold and the extreme heat are things that if you don't have a great building envelope, you need to mitigate with more heating or more cooling.
Okay.
So, yes.
And somewhat related, do you have in somewhere later on, what would be the incentives or potential benefits coming?
We will touch on that.
At the very end, yeah.
Thank you.
Next slide. Oh, this is me. It's up to me now.
Now we're up to the slide that says
So I do
systems.
need, I have to be able to,
Oh.
I can't not do this and point and
Okay.
talk. Is it going to be possible for me to do this?
You can point, the people at home don't know it's not up on the screen.
Well, at least I think you guys really see what I'm talking
We've
about.
got it here.
Maybe could I even stand and do it? Would that be easier? Let's do this.
Sure.
This is just really hard.
The only thing
Just
about
I'll just stand right
standing
here.
is, yeah, I was gonna say, let's
Yeah,
just
I'll
make
stand
sure we're
right
picking
here.
up on the mic.
Stand right here. So let's get into a little bit about the system so you can understand where we're coming from and what some options are here. We've been exploring recently. Do I swipe this way? Whew, I got lucky. So we're going to, and I brought this up, I think, in the previous presentation about looking at competing priorities when it comes to HVAC systems. Like obviously, you've done some surveys and you've said your priorities are energy efficiency and integrated design and some other things. This is really narrows in specifically on HVAC systems and the controls that go along with that. And so we've created these 15 categories, and we're going to do everybody needs to pull their phones up here in a minute because we're going to do a test. But to do a basic questionnaire to help determine what is important to this committee: low priority, medium priority, and high priority. So there's 15 questions in this survey, and you'll tag each one of these things no more than 5 per bucket. So 5 low priority items, 5 medium priority items, and 5 high priority items. So if you can take a picture of this QR code, if you haven't already. I need to text my behind the scenes person that's doing my data collection. I got a lot of tricks going on here tonight. So does anyone need to see the picture? Or does everybody have it on their phone?
They have the PDF as well, which
Yep.
I like.
So there's questions about, you know, energy use intensity or low operating costs. There's questions about acoustics, emissions implications, the number of compressors, first cost, future adaptability, individual zoning, indoor air quality, et cetera, et cetera, et cetera. So there's 15 topics in there. We'll then create, I'm not sure I can create the results here tonight, but ultimately we're going to come up and say, these are the top 5. Now, again, they're all important. We're not going to lose sight of these things, but here's the 5 things that kind of rose to the top of priorities. So when we go to actually do the detailed analysis, I can provide you
a presentation more applicable to what's important to you as a committee and as a district as you look to do these things. Is it working, hopefully?
And if something isn't clear.
Yeah, if you have a question as you go through it, feel free to ask. I'll answer as best I can. Are you both? So
I'm
12
opting out so that I
participants?
can take notes as we go.
Yeah, okay. The more the merrier. You guys can-
For those at home, do you want to give just a brief summary of the types of questions that the committee's asking?
Yeah, so we're asking various questions related to HVAC system and operations of those systems. So the HVAC system can be the largest energy consumer in a building, so we're really curious what importance that is to you as a town. We're curious about the operating costs of those systems. Those kind of tie together. The importance of emissions implications with those systems, whether, again, Dan spoke a lot about the fossil fuels or non-fossil fuels. We're trying to get that commitment of where we want to take this. First cost, electrification, operating cost, life cycle cost. So ultimately, we're going to come back to you with a life cycle cost of these system options, which will involve first cost, annual operating costs, replacement costs at whatever year systems need to be replaced, as well as ongoing maintenance costs that the town will have to keep up with. And we do that over a 30-year period, and you'll see these lines there'll be a cross at some point where geothermal will be the premium system that we're looking at here. There will be a payback that comes along with that. Ultimately, the data we'll present will show you when those lines cross in the future, and if that premium can be dealt with now. So that's the basic summary. We good?
I feel like I hope I got an A.
Okay, well, we'll see. There's no wrong answers. There's no wrong answers.
Well, people are just finishing up. Was there anything that you looked at that you went, oh, I hadn't thought about that, or, does anybody want to mention something?
Feedback about it, or
it was something
exactly
that was
what you wanted to read?
Yeah, you said only 5, and I found like top priorities, and I had a 6. So
That's all right.
like moving one to medium was
Well, I
really
wanna-
difficult because
Right,
it was
no.
like.
What I want to avoid is all 15 being high priority. So as long as we have some variation in those buckets, that helps give us some data to work with.
But I was really happy to see acoustics.
Yeah, that is important.
Because
I mean,
acoustic environment is something a lot of people don't think about and really affects.
well, the indoor environment's critical, but indoor air quality, acoustics, daylighting, all of that is critical to the environment that we'll be working to design around as a team. So we think we're good, caught up with the survey? All right, so the next slide. So we've developed internally what we think some of the options are we want to pursue. And again, this is open to your feedback. And if you want some adjustments here, now's the time that we can do that and make some adjustments before we get into the weeds of the analysis. But we are exploring 3 all-electric options. One being ground source heat pumps, like I talked about a minute ago. One being what we call air-cooled variable refrigerant flow, which I'll describe here a little bit more in detail for those that don't know what that is, as another option. The third option is we can cross hybrid between those two. We can do a little bit of both. We can maybe not spend so much on the well field and spend a little bit more on air source and kind of get a hybrid between them, mainly as a way to kind of mitigate cost and still get a decent energy performance. So those are what those 3 electric options are. The fourth option is do what you did at Marathon School. That's effectively what that is. It's a VAV system. You've got rooftop air handlers, you've got a chiller, just a very conventional HVAC system. Made sense. So that's what we're looking at. And if there's other considerations you guys want us to consider as a committee, we're happy to do that as well. So we wanted to have this initial slide. It's a lot going on this slide, and what it's trying to convey to you is what what fuel source we're using for these various options. So for the option 1A, 1A, and 1C, which should say 1A, 1B, and 1C, the all-electric options, for ground source, we're using the earth to heat and cool, to work to heat and cool the building. With air source, it's outdoor equipment that does it. The hybrid is a mishmash between those two, like I said earlier. And then if we go with VAV, we're using fossil fuels to heat your building and electricity to cool the building. That's a good summary.
So this does not, remove the possibility of like solar panels to do the electrical for
Correct.
the air source.
Correct. That's a layer. That's the next level we'll take it to once we get past the.
Where you're gonna get
And all of these systems have implications of the sizing of that PV system to be zero energy,
Okay.
which is a critical piece to the life cycle analysis that we'll get into. And then when you factor fossil fuels and zero energy really don't go together. You don't put PV into offset natural gas, so those two really don't jive together very well. So ground source heat pumps, I want to talk about that for a minute for those that aren't familiar with it. This is an image of a school that we just opened in Connecticut. It's the first zero energy school, public school in Connecticut, believe it or not. I'm not sure how it's the first one, but it is. And so again, we used a ground source heat exchanger. It's a closed loop that circulates fluid. There's not an open well or anything that would dry up like that. It's a completely closed loop that circulates water through the building to various heat pump units. And that's basically a fancy refrigerator with ductwork on it to heat and cool your space. So to your point earlier, I can heat this room, I can cool this room, whatever the occupants want. It allows me to do heating and cooling throughout the whole building kind of whenever I want. So I don't have to worry about, overheating this room because the whole building's heating right now. So those kind of, in a heat pump scenario, whatever the heat pump system is, that kind of goes away. So that really helps from an advantage perspective. So we did a real brief description here of some of the high-level pros and cons. Geo will be the lowest EUI, will provide you the lowest operating cost, will provide you the lowest life cycle cost, the least emissions implications, and is all electric and the least amount of PVs needed. So I think that's pretty obvious. It's going to be the best of all of those things. However, it comes at a premium, and that's really what we're going to weigh with all of this. So there is a premium first cost that comes with it, especially with the world of escalation we're dealing with today. It just gets like I think they escalate faster than everything else for some reason, so that's kind of what we're fighting against is escalation and really coming up with a good balancing act. One of the other challenges to the heat pumps is integrating those systems into the floor plan. We do have to work more closely with Dan and Bob to figure out where to put equipment, but that's something that we just do behind the scenes as a design team. And there's different maintenance implications that come with compressors and filters that you may or may not like, but that's just part of that system that we have to deal with.
When you talk about premium costs, can you give just a kind of round percentage estimate or something of how much more costs we're talking about than other systems?
It's 10-ish% probably,
Okay.
what we're looking at right now, plus or minus. The problem we're dealing with right now is the well field escalation, the actual well field drilling are escalating for whatever reason faster than everything else. So the well pricing we're getting back are way higher than I ever would have thought they would have been. For what we recently, the project in Connecticut, the wells bid at around $20,000 a piece, and these are 500-foot deep wells. And right now we're seeing pricing, north of 30 a piece. So that's just that piece of the system. But we're still vetting through all those numbers, which is why we didn't want to present a lot of details today, because we really want to make sure we give you the right information instead of throwing a bunch of spitballs out and give you a bunch of bad data.
And when it just talks about that percentage, just bear in mind that that's a percentage of that part of the system.
Right.
That's
Right.
the
Not the whole
percentage
project.
of the project.
Yeah.
Right. And
Yeah, I just want to clear up.
to put it in context, I'm stealing their later thunder a little bit, but this question's going to come up again. And so one of the goals today is to introduce this concept to the committee in terms of how we can talk about cost. And then we're going to continue working on this same idea so that we can give you costs that will be more tailored to this project in terms of the comparisons between the various systems. So this is really the starting point to open up this topic at a more detailed level for the committee so that we can work towards the goal of really having an evaluation.
So I'm looking at this roof right here. It's kind of a clean roof, not a lot of equipment up on the roof of this building.
This one?
The example here.
The only thing on there is PV.
That's it.
Yeah, and I have a nice aerial view, I just didn't show it. We have a nice aerial view that there's nothing on the roof except for PV. All the equipment's indoors. The DOAS units are inside, all the heat pumps are inside. There's nothing outside,
Okay.
which is another benefit of it.
Is this a Massachusetts school or?
This is in Connecticut.
Do they have similar restrictions on square footage like the MSBA does?
Yeah, I mean, they do have restrictions. There was a whole process we went through of sizing all of the program and everything else. This was a renovation. This is, by the way, a renovate as new project. It isn't a new construction, so it can be done that way too. But this was taking a effectively 1950s building that they thought about tearing it down and decided to repurpose it. So it's kind of one of those reuse projects. It's got a cool story with it too. So this was having to take a whole building and make it last another 50 years. So that's what that one is. So there wasn't as much to worry about. They did have to add to the building to get additional program.
No, I just wanted to be clear to Tim and others in the group that, the MSBA dictates our grossing factor, right, caps out at 1.5%. So we may or may not be able to fit everything within the building, and that's
Right.
previously.
Which is why you see
something-
rooftops, right?
Things end up on the roof because you
Right.
run out of space.
Yeah.
right?
It's not to say we haven't, I mean, this is one of 3 sister projects. We're doing 3 in a line. And the second and third jobs are using rooftop DOAS because we ran out of space. And so we'll have to vet through all of that.
Right, there are opportunity costs,
Yeah.
right? Building enclosed space costs us
Yeah.
more because we're building it to the
Sure.
same energy efficiency as we
Sure.
are program space.
Exactly.
DOAS,
Yeah,
dedicated.
dedicated outside
outdoor
air system.
Air system, so that's.
The fresh air component that provides the indoor air quality that we need for the students to learn. Yeah.
So there, a lot of what we hear today, don't get hung up on the percentage and the dollars because they're all part of the diaphragm, right? Like, if you only do small steps, the premiums are higher than if you go more in to the all-in approach. And so our goal is to explain to you what these different decision points are and then tailor, over the next several months, what you guys want as the ultimate design system to move forward.
And one thing that is so important that Dan mentioned earlier is about the integrated design, that getting this building envelope sized properly and getting air infiltration down as much as we can is super critical for this system because there's a premium cost with it. So I am all on board with doing that and making sure that we optimize this and get this thing sized right. I've done it a gajillion times. I want to do it again, so I know we can make it happen. But it's critical that we size because the money is in that well field. That's where the money is on this. So we have to really make sure we don't oversize that. So that's key.
Some of
to
that
be
is
successful.
I have you back up.
Oh, well, that's exciting. Oh, this is kind of fun. I like standing here.
Yeah, some of the geothermal too, because it's not a new technology, but the volume has increased in the Northeast, and so there's not as many bidders as there are for other trades. All the established trades have a large pool of bidders. So we're seeing new companies, come into the fold, and even in the last year or so, people moving out from other territories like to come after the work. So by the time we do bid this job, there will be more people in the field than there are today that are currently bidding this project.
One question I have.
Sure.
Sounds like a very sophisticated and pretty integrated system. So when at some point, if we need to expand or add more capacity, how flexible would that be?
Yeah, I mean, I think we have to consider what the immediate expansion needs would be, and we either try to get it designed into the well field today and buy a little extra capacity now, or we just have to buy it in the future. So we need to weigh both of those and see how to do that.
But it's an excellent question, and certainly it's something that we can talk about when we look at a comparison of systems, because some are more easily modulated than others over time.
There is one of the questions is adaptability that's in the survey that does talk about what is the ease of, like, if you had to add on to Marathon tomorrow, how hard would that be system-wise? That's that same question, and how would you do it, and we'll answer that within the system options that we're presenting through the survey.
With the growth of students in the school district, we're definitely seeing a need for that
Right.
adaptability.
No, it's everyone's is dealing with that for sure.
Jesse, you comfortably covered all the bullets here on the slide with the group? here?
Yes,
So this is
yeah, I think we're good with the geo option. Yes, we can move on to.
One thing I'd like
Oh,
to
sure.
add, it seems like it would limit the future land use once the geothermal is installed.
We want to put it somewhere, I mean, we are seeing a trend in the market now to them going under buildings and parking garages due to more urban environments. But we do need to be sensitive to where we place it and what your future expansion might be. Generally, they go under parking lots and they're perfectly fine there, or if there's a play field that's part of the program, we can put it under there and be perfectly fine. But we do need to be sensitive to that in the planning, yes. Any other geo questions before we move on? Okay, so the next option is what we call air source variable refrigerant flow, or VRF is what we call it in the industry. And this is a heat pump system. It does a lot of the same things I've talked about with geo. It can heat or cool individual rooms however you want. However, it doesn't use the earth to do the heat exchange. It uses the air to heat exchange. And there's a lot of limitations that come along with that when it gets to be cold outside like it is now. The low end of heating for those can be problematic. Now, there are vendors out there that do make low extended range, low temp systems to help offset that, but you have to buy bigger equipment in order to get that. So we can size those systems to get that, to mitigate those concerns, but there's still, that's kind of the low end, the barrier of what that system can handle, but they do work successfully. And we've seen those in schools, but they do go along, they have their own pros and cons as well. There's a lot of complex refrigerant piping that connects all of these together, so it's more heavier when it comes to the refrigerants that are in the building to heat and cool with, the heat transfer media. And it isn't, it doesn't adapt as well to future expansion in terms of that system. You'd be adding on separate systems. So there's pros and cons with that too that we'll get into in detail, which is my next slide. And so, it will come at a lower cost, and that's always a good thing when we're talking about these types of things. But neither you'll see both at the same time. That's okay. It's easier to integrate into the floor plan because you generally, I'm not sure if do you have VRF in any of your schools, Tom, by chance? No. Okay, so maybe we don't know what we're talking. So you can see ceiling cassettes or wall cassettes. They kind of go out of sight, out of mind stuff, so you don't worry about seeing them as much. But it does have fewer compressors that go with it, so there's less of that maintenance to deal with in terms of having, with a Geo system, every heat pump has a compressor in it, like a little refrigerator scattered all over. Each classroom has a refrigerator in it, whereas VRF, they're more centralized with that, so it's less of that to maintain. And it is all electric, so that's kind of the benefit. It's a cheaper way to do all electric from a first cost perspective. Go ahead.
Just to make clear, because I know sometimes people don't want to ask questions when they don't understand something. Heat pumps have really come into the market as a popular option over, say, the last 10 years. Is everybody familiar with what they are and how they work? Because that really is a distinction between the ground and the air in terms of how that component functions.
Yeah, without getting into my Thermo 2 class, which I don't want to do, it's just really, it's a matter of the earth is at a constant temperature, and I get better efficiency because I'm heat transferring with a constant 55-degree temperature, whereas the air is 95 in the summer and minus 10 in the winter. It's just harder for it to do the work.
I only took Thermo 1, but basically, if you have a refrigerator in your kitchen, then you have a heat pump system. And basically, you have a compressor and an evaporator, those two pieces that turn on your refrigerator, make those work. In the refrigerator, it's kicking heat out from your refrigerator into your kitchen. And so an air source heat pump is doing that when it's cooling your building, it's kicking heat out to the air. Ground source is taking that same heat and putting it in the ground. And then they just flip during the summer or during the winter.
Exactly.
So one question, I have heat pumps at home, which are obviously not the same thing, but I know that when I get into the 20s is when it starts to really have issues.
Yep.
What are these kind of larger heat pumps like where is the efficiency trade-off starting to really happen?
There's a couple of answers in that question there. So when you see, the limitation of heat pump technology is literally the refrigerant that's doing the work. So refrigerant technology has changed tremendously. So how old is your heat pump unit? Is it older?
4 years.
4 years? So it's not too old. So what you see now is there are emerging refrigerants that are changing that have better performance, and then you'll see, like I had to put a new heat pump in my house, and the outdoor unit's twice the physical size of what the unit was before, because it takes that much more surface area of heat exchange to do the work, to keep the efficiency in check. So that's what it's trying to do, is create that surface area to create more heat transferability to do the work.
So, but don't keep 20 degrees in your head. The commercial ones for 10 to 15 years have been good to about -8, -10 degrees Fahrenheit.
Okay, thank you.
Yeah.
Okay, and then what happens then? Then they work as an electric
heater. Right.
So then they have a coefficient of performance of 1 because you take electricity and that amount of energy goes into your building to heat.
That's a Thermo 2 topic, Dan.
I may have taken it. So, and if you look at your fossil fuel high efficiency gas heater, that has an efficiency of about, at best, 0.9. So you're still more efficient in terms of the energy. It's just that you're now paying for that energy through electricity instead of through natural gas.
So you're not seeing it as an end user, like you're heating your classroom or space up to 70. It's going to be at 70. It's just going to be less efficient.
Yes, And it'll take, with heat pumps, sometimes the recovery rates can be longer to heat that way because of the temperatures, but it'll all get there. We can size and engineer the system so that you really shouldn't see the end use being any different from a thermal comfort perspective and the functionality of the building, you really shouldn't see any difference. So it's just a matter of sizing the systems right, working with the vendors and the trades to get it installed properly, all of that stuff. So there's not really a limitation to it, just has to be sized and engineered a little bit differently to accommodate the variation in temperatures we see.
And just looking at your slide, higher operating costs.
Yep.
Is that because you're running bigger equipment?
It's-
I guess my question is it higher than geothermal or higher
Yes.
than what I'm using today?
It's higher than Geo.
Yeah.
Geo's gonna be the absolute lowest in terms of EUI that you're gonna see. So the air-cooled VRF is getting a ratchet above that. Yeah, and that, ultimately, I'll have more specifics next time we meet to tell you, this is what your dollars could be expected for energy. And which is why, the benefit of Geo is that you don't, the coefficient of performance that Dan mentioned, when you're doing all electric heating, no one wants to use resistance heating. But that's ultimately what an air-cooled VRF system will get to at those extreme temperatures. For the most time, you don't see that.
Yeah.
And that's when your wheel starts spinning on your meter, okay? Which is why you need a lot more PV on your site to help offset that. So you'll need more PV to get to zero energy, which is a cost factor if you want to buy it. Either way, you're paying for it, whether it's through PPA or whether you buy it on your own. It's not free, so you'll need more PV in that scenario to get to zero energy than you would with Geo. So we're going to balance all of those things so you can see the true big picture here of what those would get to you.
So if I'm clogging up roof space with bigger units, I'm assuming when we say bigger units, we're talking about bigger than what a normal HVAC unit, and obviously those range in size, but we'll just say typical, right? Aren't it taking away roof space?
We run out of roof. We run out of roof and we gotta go find somewhere else to put it. Exactly. A typical zero energy project that's 25 or less, the PV will fit on the roof. We have to study the 3-story model a little closer to see, because once you start losing roof area, it becomes a little more problematic in terms of fitting it all there. But we'll have to look at the analysis and see, what that would be, grade mounted or whether you want to put it somewhere else in your community. There's other options you could consider as a town, how you want to tackle that. But to be on-site zero energy, we'll run those numbers and show you what that would look like with the different options.
Yeah, that's what I was gonna ask. So with the 2-story versus a 3-story option, we'll see what the photovoltaics.
Well, the size of the PV is the same, just whether I can get it all on the roof or not.
Well,
Yes,
or,
yes.
Or how much shading there is, right?
Right.
So a 2-story may still have some trees or whatever that
Right.
may shade, whereas a 3-story is
Correct.
unlikely to have
Yeah,
that.
yeah.
So, just going back to your slide, higher life cycle costs, is that equipment, because the equipment's running more?
It
that
costs
mean
more to
I'm gonna-
operate, and then it will.
My replacement cycle's
Your
gonna be
total
faster?
replacement is more because it's harder to replace bits and pieces of that system because it is kind of an engineered system, whereas a geothermal system, you can just replace a heat pump unit. If the one in the classroom breaks, you just replace that one instead of the system-wide.
In some ways, it goes back to, can you put this indoors or not, right? Because if you've got air source heat pump equipment that's sitting on your roof and it's exposed to the weather, as compared to ground source equipment, which is sitting typically inside, it doesn't have to be, but typically, it will also last longer. There aren't as many moving parts.
Is there also, again, thinking back to the home, and this may not be relevant in a commercial standpoint, but can you buy insurance for things that break within much shorter time frame with these kind of units? Or is that something you would recommend, or do you just go with the typical lifestyle?
I think it depends on the comfort level of the town and what the maintainability wants to be. There's extended warranties we can buy with these systems. We kind of shy away because that can add a lot of cost that you don't really know what you're spending your money on, but there are ways to do that. We've specified projects where we get some spare parts furnished with the project, so if something does break, you could replace it, or controllers that break, so you have some stock. But I'm not familiar with if there's an insurance policy per se, like a homeowner's type insurance. I wouldn't think that you probably would do that.
Well, just to follow up too, would this be specialized technicians that would have to do this kind of replacement and repair work?
It depends on the system. So,
Okay.
so the as Dan mentioned earlier, the heat pump is as simple as a refrigerator. So if you have people that can work on refrigerators, you can work on a heat pump. of air-cooled VRF system gets a little more complicated because it is an internet-connected piping network, so there's a little bit more complication with it that may be something you don't want to bite off on, maybe you do. Something we need to, that's part of the discussion we have to have.
So my last question on this topic, so will your cost estimates factor in those kinds of things, or are you just simply assuming you're gonna buy it, it's gonna last 10 years because that's what the product said it will do, and there's no other additional cost factored in?
So it'll be first cost to install, it'll be the annual electric or utility operating cost for whatever the period we decide is, it'll be maintenance costs, and we usually, there's industry standards for square foot numbers that we would apply just to get some numbers plugged into it, and there'll be a replacement cost factor at year 20 or whatever the industry says, this system will last 18 years, 20 years or whatever, we'll apply the appropriate cost factor at that year, because 30 years is typically where we target life cycle analysis.
Okay, thank you.
Yep, sure. Any other questions on this system before I move on to the next one? All right, so the next one's really easy to talk about because it's really a hybrid of the two. Okay, so we can, and the reason we look at this as a way to potentially shift some of the first cost away from the well field into less costly system, knowing that we're going to pay, it'll be somewhere in between the energy consumption of the all air source option and the geo option. Whatever percentage we pick to go between the two is really where that'll end up. So it's really just a mishmash between those two. We'll run a couple of numbers here of what we think makes sense, and some technologies that might make sense. This particular project, the classroom wings used air source VRF to heat and cool the classrooms, and geo was used for auditoriums, cafeterias. That's probably the bigger kind of spaces, right? The gym.
So just a clarification of that so that the committee's aware. We're not talking about, say, a geothermal well that also goes through the same air source equipment. You're selecting rooms that would use one system versus rooms that would use another system.
That's exactly how this model.
That is an option of that. The other option is you can take a geothermal system that has that loop I was talking about, and you can apply what's called this is relatively newish because the industry is going all electric. Trane makes this unit, it's called a chiller heater. It's the basically air-cooled chiller that's also a heat pump. So we can buy that unit, which is conventional to your air-cooled chillers you've seen in other buildings, which is also a heat pump that we can use to supplement that geo loop. So I'm going to be looking at both of those because I think they both have legs under them that might make some sense for us to consider as an alternative for you guys. So it would take the geo system, it'd be exactly the same. All the indoor equipment would be exactly the same. It'd be heat pumps just like we do heat pumps, but the way we generate the heat transfer will be a little bit different. So we're going to be looking at both of those. So I think I covered the pros and cons on that because we've kind of already talked about. Any other questions about that before I move on?
Is there a supplemental system that can be considered that instead of using air source would use more of a conventional fossil fuel system?
Yes.
And what are the pros and cons of pursuing one versus the other?
Yes, so there is a conventional, what we call a tower boiler heat pump system that uses the exact same interior technology as geo would. Heat pumps are the same, just like I described, except the closed loop goes away, or a part of it can go away, and then you would then, as you need extra heat, you have a fossil fuel fired boiler that can inject heat into that loop to give you that. And then you would have a heat equipment to reject heat in the summertime because you won't have enough to reject either. So there's a hybrid between that you can do as well. And that can use fossil fuels as well. We've used those for, again, before electrification was a thing. I've designed, lots of those all over. It's another way to do it, but you're relying on fossil fuels at that point. It could be converted, maybe more easily converted to all electric in the future, which may be a consideration we want to be thinking about. Some systems are easier to convert than others. You got to really decide if you want to spend this money now to turn around and convert it 15 years from now. I'm not sure what your gauge is on wanting to do that, but that's something we need to be thinking about.
How many buildings do the mixed use, the geo and the air technology? Do you know? Are you doing a lot of buildings?
I try not to. I try not to mix systems if I don't have to. It just comes down to balancing cost.
That's kind of
I mean, I try not to mix systems. Yeah, there's reasons why, and it could make all the reason in the world here to do it, Tim. But we have to ultimately make the decision collectively what makes the most sense for you guys to balance cost and everything. But I try not to mix up too many things if
Yep.
we can.
No,
Try
I
not to give you
appreciate
more
that.
than 10 light bulbs, that kind of stuff. so.
Perfect.
Yes, sir.
I understand where the government's going with the zero net energy,
Yep.
and I'm all for that. However, the reality is, this school is gonna cost over $100 million. The last school we built was less than half of that.
Right.
And of course, a lot of it has to do with what happened in the economy in the last 5 years.
Yes.
But at the end of the day, we gotta get the town meeting, and they have to approve that number.
Yep.
So when somebody asks you, says, what is the payback of doing this? I know what the upfront cost is. Is it gonna pay for itself in 20 years, or not? Or in 20 years it breaks and we gotta do it again? Those are the kind of questions we're gonna get that we have to answer.
And that's,
So, I'd like to know what a similar building, fossil fuel fired, what's it gonna cost to run? What are these guys gonna pay for utility bills every month versus the new? Because if I suspect it's what you guys say, that it'd be an easy sell at town meeting. But help us, it's probably the most important question other than traffic that's gonna come down. to this.
and we will have all that data will be presented to you, so you have the numbers.
Yeah,
all
you'll be
about-
there.
Yeah. We're all about we'll have the facts.
It's really important, because, to the average guy paying his tax bills, if they're looking at, I heard the other day, they're talking about a $3,000 increase in your taxes with all the capital projects we have in line. That's a big number,
It is.
especially for
I'm
old
with you.
guys.
Yes, I agree.
You know,
I'm
so-
dealing with it in my town, so I know it's something.
So we gotta, structure this thing so that it looks and is actually a good deal for the town, not something that we're making the government.
There will be a decent payback to it, and I don't want to throw out fake numbers and get you all excited about something and tell you something different in a week, so.
Excellent.
And we wanted time to make sure we were vetting the right options for you guys so that we can give you good information.
Great.
Before we move on to the next system, just in terms of the geothermal versus air source versus sort of a supplemental approach, do you find that when you're determining for New England climate like this, do you find when you're determining the well field, because that's the largest cost associated with pursuing a geothermal option, do you find that the size of the well field is more determined by the heating season or the cooling season, or is it relatively even?
It depends on the building envelope, and so in a renovation, like the renovation I showed you earlier, it was probably a little bit more heating dominated. Generally, we find a fairly close balance, and so we're right on that fine line. For an elementary school, it typically works itself out pretty well, but we do see a trend to be a little bit more heating dominated here because it really comes down to how much you want to run your fresh air systems. And if you'd asked me 3 years ago, I'd give you a different answer, but now with post-pandemic design, we're running outside air systems longer. That shifts the scale to be more on the heating side.
I mean, it also goes to how many hours you're going to use this during the cooling season.
Right.
Yeah, I was actually gonna say that. It would be really interesting to see the difference in cost because, any kind of summer school program, we have some not new, but some special education summer programs that have been using some facilities, and it would be really nice if that could be air-conditioned space, depending on the cost of maintaining air conditioning during the summer.
Yeah, I mean, you get the good thing about heat pump systems is you buy heating, you get cooling. You're not buying another thing to get it. It comes automatically with that system. You just run it backwards, right, or run it forwards, whichever order you want to do it in, right? So
That's an important driver when they do the balance. So I've asked them to come with the scenario that we've all discussed tonight, but should they envision a summer school use of the building, because that will go into the annual utilities and maintenance and payback. Okay.
yeah.
So we'll include that as the little baseline.
So, and last but not least, is the Marathon Elementary example, or maybe it is least. Oops, I'm way behind.
Yep.
So this is what I consider maybe conventional design, what everyone's used to, natural gas heating, variable volume air handlers. So you can see there's several rooftop units on there. And you've done a pretty good job of balancing PV on there with the rooftop units. So, but there is shading that comes along with that we have to deal with in that rooftop, which we would do during the design anyway. So again, it's a similar way to do something, to heat and cool your building. It's a VAV system, so there's variable air volume system is what that means. And so it's all heated and cooled by air. And we have hot water that's generated by hot water boilers, and as Dan said, that efficiency could be upwards of 90%. So every BTU of gas you input, you get 90% of that out for the work. But in today's market, gas is still cheap, you know. So when you start comparing gas and electric systems, gas will still come out as sometimes being a pretty economical way to do it. But there's emissions implications that come with it. You have on-site emissions that come along with the system that you don't have in any of those systems we talked about. That's kind of one of the fundamental questions as a town you have to be able to answer or discuss with yourselves of what's important as a town when it comes to that. But you've got these systems all over the town. You're used to them. It's pretty conventional stuff.
If the gas cost is less expensive, why did you list under the cons that a higher operating cost? What drives this as a higher operating cost of the fuels?
Because it's a typo.
Just wanted to clarify that.
It's still going to ultimately, life cycle will still be higher, but yeah, that's a typo.
Agreed, yeah, life cycle.
Yeah.
And when you come up with these projections, I'm kind of answering my question, but bear with me.
Sure.
When you come up with the expected costs going forward, is it all projections into the future, or do you actually look at existing net zero schools that are already out there and see what they've actually
That's what
received?
we do. Yeah, we have 10 million square feet of zero energy buildings. We'll look to that data to tell you how they perform, where they need to be. Yeah.
And how far back does that go?
We've been doing these since the first one we did was in 2012, 2011.
So a few years.
A few years, yeah. And you know, there aren't as many of them up here in New England, so that's always the question we get. Well, you can do it anywhere, but New England's so different. We can't do it up here. It's just too cold. It can't be done. Well, you know, it can be. We just have to size and engineer it properly. So the school in Connecticut is close enough. You know, as far as I'm concerned, it's close enough. So we just have to size and engineer it properly to get there. And that's what we'll be doing as a design team. Yeah. It's even easier to do in new construction because I have total control of this building to get it to design right.
And we have buildings here that are.
Right.
And is there,
yeah.
But is there a breakdown? I guess I just want to make sure that when we present these numbers, you know, to Mike's point, if someone were to say, well, are these all just guesses going forward? Are they all actual past results, or is it a combination of both?
I have real results for geo schools. I have real results for air-cooled VRF schools. I probably don't have anything of the hybrid option, but I can extrapolate between those two because that's kind of, we're doing that. We're seeing that kind of emerging with some clients because of a maybe cost mitigating strategy. And the VAV, we've got data for that too. It'll be built projects.
So
Okay.
One question.
Not
with
modeled data.
One question with the VAV, the net zero doesn't apply, and that's an incentive rate. So MSBA gives us a certain percentage or something.
To clarify, the MSBA gives it 2% for being green, which is the LEED program, so Leadership in Energy and Design. So that's independent for net zero. You know, net zero is a different category. And it's not something you need to get in terms of the plaque on the door. People used to want to get LEED for the plaque on the door. Since that point, the MSBA just wants that it's certifiable and can maintain a certain level, and you get the 2 points. LEED or net zero is another program that you could still be a net zero building without going through that program. Not going through the program allows you more lateral, right, to interpret versus the rigidity of an actual program. So you can be a net zero building and still have fossil fuel. That's controversial in some people's opinion, but you know, being net zero is getting to a balance of the offsetting your operating costs.
Yeah, I'm not sure. We have to talk a little bit more about how you would get to net zero and be burning fossil fuel.
But with net zero, are there incentives?
Yes, that's
Okay.
2 slides down.
Because I guess the reason I'm bringing that up is, you know, if we're talking like traditional systems and, you know, you see some lower costs and stuff, it would be nice to balance it out by saying these are the incentives you lose if we go with this option.
That's all part of the math.
Yeah.
Yes. Yes.
And to take it one step higher, possibly, when this committee was put together about a year or so ago, I happened to find an article from last year, November of 2021, that right in Westboro, they built the first net positive school. Is that another whole level of potential costs and or, to her point, maybe incentives, or there's no incentives for net positive versus net zero?
There may be some. I would say it's incremental at that point. I mean, I think likely if we're designing a net zero energy building, it'll be net positive in the beginning because PV degrades over time, so we want to put some safety factor into it. Now, if you want to be 30% net positive, that's a different story, and you would buy 30% more PV to do that. So there are costs that go along with that you need to support.
Okay.
So that's how you do that. Do you want to spend your money that way or not? Really, is what that comes down to.
It was surprising, that's the first one. You would think there'd be plenty more, but maybe
Yeah.
it's a cost factor.
Yeah, I mean, I think we're doing great just to get to this point, right?
Yeah.
So,
I think there's a new wave of schools coming that have opened up in the last 5 years. So I think the net zero conversation in schools more specifically has been a growing momentum, for all the reasons that have been stated tonight, that there's still more and more schools that are getting on this program with more in construction that'll be opening before you even finish your design. So there'll be more data. Okay.
Correct. That's correct.
With the,
Go ahead.
with the PV discussion, are we discussing purchasing or leasing?
That's
of
up to
PV?
you guys.
But are we gonna see cost?
Yeah, I mean, I think we're going to ultimately look at the cost as if you were to buy it. If you decide that you don't want to buy it directly, want to indirectly buy it through PPA, that's just a way to shift money. So whereas if you were to buy the PV on your own, that will truly give you the lowest operating cost
Yeah.
physically, because you'll only be buying what you take off the grid, and whatever you put back just nets it out. So you still would be paying for electricity, whereas a PPA, you're buying the PPA from a solar provider and you're paying that company some reduced rate of every kilowatt you consume, you still pay for. So the math isn't quite the same.
Yeah, and with the own PV, if we're a school district, do we get things like smart program incentives and things like that, like Eversource gives, or is that a completely different?
We'd have to check and see what that would, I'm not
Okay.
sure offhand. I'm not
Okay.
sure offhand.
The programs change year over year too.
Yeah.
The
Well,
programs that
right,
were
that's
around
why I
2
was
years ago
wondering.
are kind of January 1st,
Yeah.
they'll probably flip over to something. new.
Right, part of the reason I was wondering is because, I know the residential incentives, so I was just
There are-
wondering what crosses over
Yeah.
into a school district and the incentives that you would get from solar.
And I'm still working to actually have conversations with Eversource about because their incentive programs have all changed recently with more emphasis on heat pump type of systems. So we're looking to see commercially what that means and how that might even apply, and I've got a slide about that
And how it
here in a
works
couple of
with the
minutes.
MSBA.
Yeah, and how the MSBA wants to grab at that, so let's talk about that.
That actually feeds well into my question. So just before we leave the natural gas option, one of the things that has popped up recently, like in the last few years since the war in Ukraine started, is the massive fluctuation in natural gas costs. And so when the town gets those numbers, will they have a way to forecast how the changing cost of natural gas has affected that energy cost versus something like a PPA or purchasing your own solar, which would be more stable in terms of an ongoing energy cost?
So we have a performance contracting division within CMTA. I'll go back to that team because we're projecting out these performance-based contracts over 10, 20-year periods. So I'll go back to them and see how we're escalating and trying to account for all of that stuff, because it's a huge variable. And
We might
it's
want
who's,
to do a range for that.
yeah, and it's it's a matter of what kind of percentage of escalation and inflation do you want to account for with electricity and for natural gas. Because, there's one trend that could say, if Massachusetts has committed to having a clean grid by 2050 and fossil fuels have dropped dramatically, the costs are going to have to change, right? It doesn't just cost the same. So we don't really know if that's going to escalate quicker because of that or not.
But the other side of that is that if this committee was looking at building a school 2 or 3 years ago and someone told you that gas prices are suddenly going to jump 50%, nobody would have believed us.
Correct.
So
Correct.
I think we're past that. I think it's higher than that in the last 6 months.
Yeah, I mean, it just makes it a little bit easier of a decision to make, but it's still got some economics with it that have to, it warrants the discussion. Otherwise, I think we're here because of that, because we think it's going to save us some money, so that's what we want to be talking about. Any other gas questions or that kind of stuff? So ultimately, the deliverable we're going to put together is going to be this spreadsheet. And I've kind of hit on all of these kind of indirectly through all of it. So we're going to be looking at these options. There's some subsets within there that'll be part of the analysis. Again, we're going to look at first cost, the energy intensity, what the cost for PV would be to get to zero energy, potential rebates and incentives, and what your on-site carbon emissions are going to look like at a high level. Just that gives you a quick snapshot of what the options are and what that means. And then you go to the next slide, this is what the life cycle, actual dollar amount will come out to. So we look at first cost, energy cost, maintenance cost, replacement, which will then ultimately get us to a 30-year life cycle. And we'll give you all the assumptions we've made with that in terms of those ranges. I think ranges are probably more appropriate at this point anyway for what we're looking at, but that's kind of what it'll look like. Ultimately, we'll put together some more, sometimes pictures are worth 1,000 words, so we'll give you some diagrams, maybe easier to analyze than looking at a bunch of numbers and spreadsheets and bar charts and all that kind of stuff. So we'll present it to you that way. And ultimately, whatever you need us to give you to help present it to the town, we'll do whatever you need to help sell it. If I need to be there with you, I'm happy to do that too. So whatever we can do to support, whatever you want us to support, we're there to do that.
And while those will be based on an appropriately sized building to what we're planning, those are relative costs, similar to the way that the PDP estimates were relative costs. They're a way to understand one system versus another, as opposed to giving you the price that your system will cost when we build design and build this building.
Correct. And we're basing it all on the larger building at this point too, the 169,000 square foot building for all the analysis. Okay, last but not least, so the financial incentives. So the big wild card here with incentives is what's MSBA going to do to us if we even try to go after these? Are they going to take the money from us? So that's a question we're asking, trying to figure out on our own. So we know Mass Save is a big, that's kind of what we were talking about earlier, is Mass Save has very aggressive incentives for deep energy retrofits, and you can see, well, you used to be able to see what the chart said.
Hold, please.
But they give you ratcheted savings of rebates based on whether they do air source, VRF, or ground source, and you can see them stair step and ratchet. So
The, that hybrid, you called it a mishmash,
Yeah.
so that have air source, ground
Yeah.
source, building, that's under construction now, about 250,000 plus square feet. About $1 a square foot was the Mass Save benefit, so $250,000. I mean, it's gonna be finalized, but it's somewhere between 250 and 300,000.
And the Mass Save equivalent program in Connecticut for the school I showed earlier, Buckley Elementary, it's a 60,000, 65,000 square foot building, and they got a check for $267,000 back for all that. So there's real money there to be had. What we're nervous about is, do you as a town get all that money back or not, or does MSBA want to swoop it away from us? So that's what we have to figure out.
Yeah, MSBA is not gonna take it away. I mean, they've gone away from that. They used to.
Okay.
Right? But
Well, that's a relief, so, because there's even a bigger number here that gets me excited to talk about. So the Inflation Reduction Act that was passed, everybody can have their opinion about inflation. Most of it's negative, but a good thing that came out of it that could help you as a town is the Inflation Reduction Act allows state and local governments to receive rebates and incentives that used to only be available to the private sector. So like if I was building my own office building and I went to put geothermal and solar PV, I could get a 30% tax credit on my corporate income taxes. Now what they allow is upwards of a 30% rebate to you as a town of 30% of the cost of that mechanical system and PV if you buy that stuff directly. Okay, that's some real dollars here. That's some real serious dollars that we'll look at, and we'll balance all of those out when we look at the numbers. So it's relatively new. We've got a team of crazy tax advisors helping us kind of figure all this out as we navigate through all this, but there's some real money to be had there that literally can easily change your decision. If I can knock 30% off the cost of a system, I can throw the mic down and walk out. So that's what we got to be able to show you in the next time we get together.
And a piece of those incentives and rebates that's good to keep in mind, because we see this misunderstanding with a lot of clients. The incentive is there to entice you to upgrade to the next step. It's not there to pay for the system.
Right.
And so it's often a carrot to lead you towards a more efficient option, as opposed to buying you a more efficient option just outright. So when those incentives come in, if the system costs $1 million, you're not going to get $1 million to replace that system. But you may get a slight incentive that's the difference between the standard, that often starts as the difference between the standard system and some of the upgrade costs.
Right. So the federal government, set aside $370 billion into that fund for that, so that towns and communities can invest in green technologies that otherwise may not be accessible or deemed unaffordable or too much of a premium. So that's what it's for. It's for you to be able to get that. It is not, it's money you get after you've spent it though. So I have to caution you, you still have to come up with $100 million or whatever to build the building, and then the money comes back to you. And you can invest that either in your next school building or in buying PV with it, or however you want to do it. There's ways you can use that money to help fund some things, and we'll help you through what we think might be some strategies for that. But it's, it's some serious cash here to help. That's
So
next steps.
I think we talked a bit about the next steps, but we're gonna fill in some of the project-specific data.
Yeah.
And we're gonna come back and talk to you about them. And in January, we're gonna be sort of folding this in with a lot of other project assumptions about what's the structure, what's the material, what's the how do we define the building, how big is it, and then that goes into cost estimating as sort of a basis of those assumptions that then will evolve as the design evolves in terms of fine tuning. And it's not a final decision about what the system is, but it's something that we can hang our hat on in terms of it's associated with a project description that has a cost estimate associated with it. And then we still have some flexibility in terms of how we implement that.
And I have some initial results from the survey for those that want to hear about it. So I have to analyze a little closer. It's hard to read on my phone and understand exactly what I'm reading, but low EUI came to the top, acoustics came to the top, and indoor air quality came to the top. Those are the three that rank the highest out of the 12 of you that
those
voted.
go along with energy efficiency and wellness. Interestingly,
Right.
You're consistent.
Yeah.
So
Your least important was PV size, space considerations, refrigerant global warming potential. So, but I'll put all this together in something much more legible than me just rattling off a bunch of stuff here.
So the intent that we discussed tonight is for them to come back to us in January, and once they've developed a lot of this information. Right now, we're basing it off the 4 systems that they presented to us. Based on the discussion tonight, are there any other of the options that we casually discussed that we should also be studying, like geothermal supplemented by fossil fuels, or any of the other options that you're aware of that you would like to see as part of this discussion?
I think it's difficult to say at this point, right? Without knowing costs of anything. I think right now it looks like, there's a high end, middle end, and kind of low end, right? Mm-hmm. And I think it's tough to say if we do, where does that fit in? Part geothermal, part fossil fuel. It doesn't sound like you guys have done a ton of that. I'm guessing it's just engineering.
Yeah, I mean,
To
there's
suggest,
nothing that says I can't do it.
Yeah.
It's just a matter of, is that what you want?
But Tim, I think that's something that maybe we should say explicitly, which is these systems are tried and true.
Yeah.
They really are tried and true, and we can take you through examples of each of them working. Maybe not in the same. If we end up with a mishmash, maybe not with the same mishmash, but I mean those could be co-joined buildings.
Yeah, mishmash sounds bad, but it's really not.
Those could be co-joined buildings that one side of it is one thing and one side is the other. The systems are tried and true and improving all the time.
Yeah.
In terms of reliability, in terms of the temperature, that they work at, and so forth.
An air source heat pump technology has come a long way in the past 5, 6, 7 years. I mean, a long way. A long way.
But I
Yeah.
think,
Go ahead.
I think in terms of hybrid, though, so it almost sounds like if it's going to be 2 separate systems, it's almost, I don't know about how anyone else feels, but it almost feels like it's a lot of extra equipment and work without a huge amount of benefit to it. If there was a failover to the hybrid, then that might be interesting.
Yeah, there's an integrated hybrid solution that I've got that can address that as well. So it's going to be there'll be kind of 2 prongs under that hybrid option that we'll show you.
Okay.
One that is truly you know, A and a B, and one that's more of a blended.
Yeah, because
More of
I
a
think that
system.
would be more
Yeah.
interesting as
Yeah.
a, because then, yeah, exactly,
Yeah.
it's a system.
So I guess, and, you know, I'll go through you, John. I guess the idea would be to kind of identify the three systems, kind of keep going down that path, and then figure out where we are once we see what real money looks like in between that. Because I think, to Chris's point, you know, maybe we don't need to go back completely to fossil fuels if the cost happens to be outrageous. But I think without any of that information, we can't give a direction on what a couple of other options would be, right?
Yeah, I mean, again, up to the committee, but I tend to agree with you. I feel like if we throw out other sort of imagined options that we come up with, it's based in nothing, right? So I think if we can
It's
see.
not nothing.
No, right, well,
I'm with you.
it's based on the extensive information you've just
That's
provided
right.
us, but
That's
without
right.
the dollars,
That's right.
it's just,
Agreed.
we don't even,
Yeah.
we could be throwing darts.
Agreed.
So,
Agreed.
so I think, yeah, the more, I think in January, when we start to see what those numbers look like, then we'll have a much better sense of where we are on, you know, those options, or if there's sort of a gradient in there that we fill into more.
It'll be a
So-
lot clearer in January when we have the data to support it. And I would only ask, is there another tried and true system in the town that you've applied that you prefer or like beyond what I've already said, or is this?
Or that you don't like.
Or that you don't like, exactly, or that you don't like. You know, this isn't gonna be a heated only building, so I know you have a lot of those, that's pretty popular, and we wouldn't be doing that, so, you know.
To that point, at some point, this group is going to have a discussion about what is that environmental profile, I'll call it, the sort of, what's the word again? The commissioning sort of standard for what your indoor air temperature is.
Thermal
gonna be,
comfort?
Yeah, your thermal comfort level that we want to pursue. We see some schools that decide they want a temperate summer because they're not going to use the building much in the summer. We see schools that want full air conditioning available. We see, you know, a range there, and that has the capacity to greatly change the profile that you're sort of working towards in terms of satisfying these options, and the ability to change the cost. Where does that typically fit into your design process as you're evaluating these systems?
I mean, I think initially I'm looking all in. We're gonna be looking at going all in, and if we wanna cut back from there, we can cut back. If we decide we don't need air conditioning in August, then we can look to downsize if that's something we can do. I think most people would say we ultimately need that flexibility, and I don't wanna commit to that, not having that flexibility.
Well, the initial indication, I think when we asked that question before of Dr. Kavanaugh, was that we would want to see it with the ability to use that in the summer. So that,
I mean,
yeah,
it makes sense. If it's got the capability to use it, you could, why wouldn't you?
yeah.
And what we're seeing is that summer is happening in the spring and fall more often than it used to a significant extent.
Absolutely.
Yeah, and I think it would get into a little bit of a controls discussion as well, depending on what system we went with, you know, because we're not using a full building, you know, and I think of the ESY program at Marathon School, we're using 6 classrooms, the gym,
Right.
and, you know, whatever. So to be able to kind of choose those spaces to cool while
Yeah, if
we
we-
let the rest of the building be
Exactly.
tempered at some.
Exactly. If there's a way to understand or predict what you might do and being able to shut areas down or wings down to save energy, that's a bonus.
Another thought I had, and it's kind of a design thought, is, you know, when you're talking about the envelope, when you're talking about conserving energy, what that leads to images in my head is sort of that building in Connecticut that you showed. It's mostly brick all the way around. But we've been talking about wanting more outdoor spaces and more sort of integrated learning. And so it'd be really nice to understand how we could get the energy efficiency with that sort of open feel for the students, so that the school building doesn't feel so enclosed, you know? So that would be amazing to see.
I'll leave that to the architectural team.
That probably
Yeah,
provides a good segue to our next topic.
With that, I may sit down over here.
Thank you.
Thanks, guys.
Thank you so much.
I don't want to prematurely end our discussion, John. if there's
No, I think that's
anything
fine. I mean,
further,
I was
but-
just going to say, from experience with the last project, I mean, those are the kind of decisions and discussions we'll be having. We had a lot of discussions around classroom window sizes and shapes
Right.
to drive those very variables, and they'll give us what, you know, what's the cost, what's the impact,
that's
all
what
of
I
those
was
things.
thinking,
So
is
we'll
it would
be able
change
to make those we're not, and stop me if I sort of step out of school here, but we're not making these decisions sort of consecutively. We're making a lot of them kind of as the entirety of, as the building as a whole.
Yeah, that's what I
Yeah.
figured, and that we want to know the differences in cost if we wanted that open field.
Yeah. Okay, thank you very much. All right.
Great, so we're going to show you in the 4 days since we submitted the PEP, an options update. So it really doesn't go too deep, but just starts to maybe prime what we're starting to look at, and we're always happy to get feedback. Obviously, no decisions or anything tonight. So where we are now are, these are the 5 options. We've got obviously the 2 sites, the 2 grade configurations, and an ad reno. We also have the base repair for cost comparison purposes, but I don't usually consider that an option. But these are the 5 that we're moving forward with under study in this next phase. And we're really going from test fits to actual designs. So what that means is we've got to circle back in the time since we started the test fits and even did the preliminary program. I shouldn't use that word because that was the submission, but our initial space summary was a snapshot in time. We've learned a lot more since then. We've completed the entire visioning process. And I'm not pretending to capture everything from the visioning here, but these are a dozen things that came up repeatedly in the exercises or were some of the more emphasized priorities. We don't necessarily just distill it into these 12, but these are also reflected in the educational plan. I would say the exception might be the last 3 or so are probably worded differently than what we might see in the educational plan, but just quickly to go through these: warm, welcoming, and safe. You know, safety and security was really its own thing, but a lot of back and forth mention, a lot in the educational plan too, about creating that warm and welcoming environment, but also having it safe and secure. Scaled and age appropriate can be a number of things. It'll get into some of the detail of design, but there's also things that we'll see at this level, this planning level, that can start to show how we break down the scale of the building. The small neighborhoods of learning, or the classroom clusters, is important. The indoor-out connections and outdoor learning, transparency and visibility, as well as display of work. Flexible and adaptable, and that means the rooms themselves to change for different teaching modalities. It also means, obviously, over time, expandability. We know breakout spaces was described pretty significantly, and that's both for use for the general academics, but also for pull-out services and for differentiated learning, creating different spaces, extending the teaching and learning that happens really anywhere within the school, and creating variety. So STEAM and the Media Center, we heard some exciting thoughts about creating a hub, maybe dispersing some of the Media Center, but creating sort of that central hub to the school. Sustainability, which we heard about tonight, but also as a teaching tool. I think this came more purely from the visioning, not necessarily in the educational plan, but the building itself can be part of the educational experience. And classroom and teacher personalization. This is one that I liked, and it also came up in the visioning process, but the culture that's been created, within the school, but within the classrooms as well. So there may be a way, we won't see it at the planning level, but when we get deeper into the design, we can design spaces that can kind of be owned a little bit more by each class and by the teachers. And good citizenship and community, all Hillers, was something that came up as well. And that also includes community use and zoning the school in a way that can be easily utilized and conducive. And last is universal design, and this was termed differently in the educational plan versus what came up in the visioning process, but it's really the same. It's making the school an equitable environment, and it's not just about physical barriers, it's about cognitive and social emotional. So this is, again, something we're not really going to see at the planning level, but these will be some of the things that we'll be building in. So what's not fully visible, I would say, is the scaled and age appropriateness. That'll get into some of the details when we get into the classrooms and the corridors and making a journey within. At the planning level, we might see the ability to organize rooms and have a pathway that goes from the inside out of the building. But some of this will be in the details as the design develops. We don't necessarily see the transparency and visibility. We'll see some of the flexibility and adaptability, which I'll show. Not all the sustainability elements are visible at the planning level. Certainly the school as a teaching tool wouldn't be, and same with the last three, the personalization of rooms, the good citizenship, that could be in graphic form as the building takes shape, and really, or even metaphorical in how we theme the interior spaces and create kind of journeys and outdoor spaces, but again, not so much visible at the planning level. So as far as concepts, what we're starting to do is look at, there is some value in test fit. It wasn't just a test fit. It was put together with short little learning communities. It's what you might call a village or a main street. So when you enter the school, you might see the landscape outside. You might see some outdoor learning, sensory gardens. It puts the community spaces that are in yellow up front, and that can be a good and a bad thing. That can create, for scale, we want to make sure that we create a scaled approach to the school, and there is a way to do that with these spaces. But it creates a clear zone for community and activity use, and then all the academic wings off of a main spine that could be considered like a main street that connects everything. So that is one kind of conceptual option that we'll be continuing to look at. We also thought of maybe mixing it up a little bit and creating something called the crossroads, where there may be landscape inside and out that really defines the central space of the school, and the academic wings and the community spaces kind of connect to that almost equally in the center. And another option is pinwheel. So in this case, we've very visibly put the media center at the heart of the school. We've moved the academic wings around so they're kind of their own neighborhoods. And in doing that, it creates voids, or really connections, opportunities out into the landscape. These are definitely not the only way to develop the concept, but these are some initial ways to just sort of rethink how do we organize the school. And as we start to put these on the site, or we start to work on the sites, we'll probably come up with more of these, or be changing some of what we see here. So what I wanted to do is maybe just point out by example, when we look at something like this, is just the example of the pinwheel plan. When we say warm, welcoming, and safe, that may be, you can see the number 1 in the green space as you approach the main entry. So part of what's going to make it feel warm and welcoming is to have not only good pedestrian access, but an experience as you enter the building, seeing landscape and an outdoor space, and as you approach the building. When you get inside the building, part of the warm, welcoming, and safe is the greeting, is the controlled vestibule for safety and security. If we look at the small neighborhoods of learning, each one of these classroom wings really is a small cluster of classrooms, and there's a lot of different ways to organize them within each one of those wings. We're showing, in this case, breakout spaces that are shared by every pair of classrooms. That's just one way to do it. But it creates those small learning neighborhoods. The indoor-out connections is part of what I've described, so I just, number 4 on the list here shows where there are a number of places where you are maybe in this building, and you'll have those connections to outside. The flexible and adaptable at a planning level, part of what we'd be doing, we've talked about some of this, but making sure that we can add on to the building, so the major spaces as well as the academic spaces. But we'll also be working, if you look at the zoomed in classroom wing, we work in modules, classroom modules. So if we have 2 half classrooms and we pair them together, that just creates long-term flexibility to convert that into one large space in the future. Let's see, what else do we have? the breakout spaces, which I started to describe. This is just one version. I'll go through a few more of those. This pinwheel option puts the media center and the STEAM literally right at the center of the school, so it's in close proximity to every neighborhood. And then from a sustainability point of view, there's a lot that you can't see, but at the planning level, what's really important is to, I think I've highlighted the north arrow, is to make sure that your academic wings specifically are on a good north or south facing, because it's controllable daylight. In the north, it's very consistent. In the south, overhangs would help you really mitigate the light into the school. We can also utilize it to bounce light, so it's the east and west where it's not as controllable, and some of your schools are probably kicked on that access, and usually you'll see shades pulled and usually not put back up. They tend to stay in place, but this is both energy efficiency, but it's also conducive to learning. And up to the side, these are just some examples. This happens to be the Zervis Elementary School in Newton, and some of the feeling as you approach the school, creating that warm, welcoming approach. In Newton, they actually had us design a parent gathering space because it's part of the culture there, that they would intentionally meet. In Brookline, I think I remember, they would actually come into the school from every possible direction, and so it was important to have space within the school for that. And then age appropriate, making sure that the spaces are tapping into how students learn and how you can reach them through discovery and through play. So there are spaces where that can be part of the design. And the bottom image here just shows a cafetorium, but bringing in natural materials. It has a biophilic quality. There are studies that show that it has a calming effect, but the supplemented by views to outdoors also can be very visually satisfying, and a way to connect the school to the landscape and to all the outdoor learning. So if I zoom in on a classroom wing, these aren't the only three ways to do it, but these are just three examples of how the neighborhoods can be organized. So with each one of these, you'll see a group of 6 classrooms. That happens to be an increment that works with the number of classrooms that you'll need, 36 classrooms, for example, in a grade 2 to 3. So the breakout spaces can be these little rooms that are between every 2 classrooms. They may or may not open to the corridor and become part of a larger space. The middle one shows alcoves, so maybe a more personalized environment where 3 classrooms really have good visibility and connections to what might be corridor, space out in the corridor or outside of the classroom. And then the last one, and I included the picture of a built example, is actually using the corridor. So in this case, and we did a square foot study where instead of building separate rooms, we built a 20-foot wide corridor, and there are rooms within the middle of the corridor, so it creates 6-foot passing aisles, and directional traffic is the way the school uses it, so you have 12-foot of corridor effectively. But the net effect of it is really you have almost no corridor, because the space between that 20-foot wide space becomes what you see in the picture here. So you can egress safely, you can get past it, but what they do is they have the neighborhood of 4 classrooms. I think they call this the front porch, that all face out onto the space, have great visibility. Students go out and collaborate, or they just work independently, or maybe receive support services. And it's also supplemented by rooms that close off so that there can be kind of quiet learning or different types of space. In a way, I shouldn't go here because we're not going to get into this level of detail in the next phase, but I want to let you know what we do think about. So this might be a standard classroom. It doesn't have to be square, but we've learned that to bounce daylight effectively into a room, this type of proportion is what you would want. The more narrow it is to the exterior and deeper, it's harder to get that good daylight and consistency of light throughout the classroom. But within this, you can see that kind of shaded triangle. And we hate to have to think this way, but we can create that good visibility that we just saw. In fact, these rooms are designed this way. That's looks like a generous amount of glass, but within each one of those rooms, there's a natural get out of sight zone. So a teacher can shut a door. You do not have to pull a shade. Students can line up. In that case, we did color-coded squares, but it just gives a visual cue to naturally get out of sight. Some safety experts will say that that's preferred over pulling a shade, which is a signal that somebody's in the room, and so you just want to naturally get out of sight. All the spaces in the building will be looking for natural out of sight or refuge or evacuation throughout. But what is also part of a 21st century classroom is, or even high performance in the upper left. This school in Newton was designed with only 24% glass. Most schools have closer to about 60% glass. And you wouldn't know it if you're in the school because the daylight is incredibly effective, but we also used, in between the rooms, you can see there's a little bit of glass, so every room feels like it has a corner window. It's borrowing glass from the neighbor. And so you're using less glass, but you're getting double the benefit from it. And in this case, we had a lot of conversations about, is that a distraction? Are kids going to be making faces in the window? And it goes away very quick if it's even an issue at all, and it becomes part of the behavioral norms of how kids work within the space, and in this case, not a problem at all, but we can of course do a tour or ask them. But what we do is, with this limited glass, we also show here a light shelf, which takes the light that's coming in and bounces it, magnifies it a little bit back up to the ceiling where it's reflected. The rooms would typically have not a single teaching wall, but really dispersed, so that the teacher can choose where they may want to teach from, but also so students can break out into groups at every side of the classroom. It's again, you got the natural visibility. Storage is critically important, and of course we hear on every project, but in every school that we've talked to here, that there's generally not enough storage. I'm not sure if the high school qualifies because there's a lot of storage there, but maybe they would say the same thing.
They would say the same thing.
But the in-room storage is important, and potentially a water source as well for project-based learning and for more active learning that occurs. So you won't see this. You'll just see squares on the plan. But there are layers and layers of flexibility, of safety and security, of high performance features that are just going to be built into the school. And I use the classroom as a typical building block just to show that. And that's our 4 days.
That's great.
Any question? Yeah, I have a question. Can you go back to the 3 designs? So with the very first one, the village, which is the one we've been using on the test fits, the one question I have is, if that shared area is right in the front when you first walk in, how busy, so we want the kids to be using it, how busy will it get with foot traffic from other people moving around the school? Will it still be a comfortable place for the kids to gather and have fun, etc.? Or would it just be, because it's so far forward, would it just get so much foot traffic that it might be a little uncomfortable?
It does become the main street, but classes of students would come to the gym, or waves of students going to lunch would go to the cafeteria. This doesn't actually show the music, but the music would be a big part of that, paired together as well as art. So it would be sized for that, but it wouldn't want to lose sight of the scale and still the acoustics. You can have a very large space, even those teaching spaces in the corridor, that could potentially be a busy place, but they're designed acoustically just like a classroom. And Tim may appreciate it's the same tile in the classroom that's in the corridor, so you don't have to go looking for 2 different tiles.
Yep.
It's high performance, so some of these things, it's not deep enough into the design, but it would be sized to handle the traffic, but it could still be not overwhelming.
For children. Okay.
Yeah, with the visual breaks, with good acoustics, and there's studies too. These aren't very long classroom wings, but even incorporating some curves, maybe not into the exterior of the building, but softening or having faceted or kind of gentle curves like this is showing a little bit, can be soothing. That sometimes intersections are jarring, or angular profiles, so when you approach a school, For some students, that may be exactly what gets their heart rate moving, that may be what sets the mood or the tone combined with something that happened early in the day. So thinking about those qualities, that's part of universal design, is to think about how it's perceived by all upon approach or as you navigate through.
Thank you.
I have a question. Can you give an estimate of timeline of when these types of decisions will be made, the detail that you're getting into now? And maybe more importantly, how do we keep the community involved, or would they have say in that kind of a detail, or is that left to more of board type decisions?
So the level of detail, like the classroom?
Just everything you're going through as far as whether there is outdoor classrooms, whether there are these kinds of things versus, again, a lot of people are used to traditional schools. I understand there's at least one or two more community forums. Do you see a year from now before these decisions are made and several community forums on this kind of design? Or are we past community involvement once we get into this kind of detail?
No, I think we'll always have community involvement, suggestions, thoughts, and reactions to the plans as they develop. These will be built into the planning options that you're going to see because they must represent the educational plan. And these things are all put into the educational plan. They were part of the visioning. When we get to the end of this phase, which is just 3 months,
April. Well, the decision's the end of February, so middle of February, so 2 months from now.
It's got to be built in because when we submit to the MSBA, the first thing they're going to look for is, does this plan reflect the educational program? There's a meeting they have called the Facilities Assessment Subcommittee, FAS, another acronym. And in that one, it'll be the superintendent and myself. Dr. Kavanaugh will present in short form the educational plan, and then the architect will need to demonstrate how the design, so any one of these designs that you pick must embody the educational plan and the objectives. So I hope that's answering the question. It's going to be built in because it's been part of the process to date. The community will always be engaged. When we get past this phase and we've got a single option and we're developing it schematically into the detail we saw in the classroom, we'll be meeting with faculty and educational leadership, school committee, the building committee. We'll see that get developed into the details.
Okay.
So yeah, I was gonna say, I think from a process perspective, from a community engagement perspective, I guess look, at the end of the day, when you say does the community have the opportunity, they have the opportunity to approve all of this because they have to ultimately vote on it at town meeting. What we'll be doing is continuing to have as many opportunities, forums as necessary to get guidance from the community. I think from past experience, it's going to be rare that we're going to put up 3 options and have a community forum and say, vote on it, right? That's sort of what we're tasked to do, is figure out how these then fit into the educational plan and then go tell that story of why the building looks like this. And so, but all along the way, continuing to gather that prioritization level input from the community so that it can inform our decisions and make sure that we're answering those questions.
I appreciate that, and I think it's going to work fine. It's just that for most people, this will be a very different looking school than anything they've ever seen, probably, at least in this town, unless they came from other towns. And I just want to make sure they're aware of all the potential differences that, instead of just saying this is the way it's going to be, and we're going to have all these different things that you've never seen before. I just worry a little bit about the acceptance of that without having some prior knowledge and maybe even some input.
So at this stage of a project, I always tell clients that all feedback is valuable feedback, because what you like and what you don't like can influence things in the same way. And it can be, you don't want to see Bob go off on a long tangent with a study that's based on a core that you don't like, because you're never going to like that scheme. And so the more that feedback comes to us from this committee, from community members who are watching at home, it lets them adapt the multitude of schemes that they're going to develop over the next 2 months so that they can arrive at a concept that works. When Bob shows you those 3 concepts, if you look at that and say, I really would like to see something that has this as its core, whether that's the library, the cafeteria, the gymnasium, the public use spaces, you know, if those fit really well into one of these schemes and you can share that feedback, that's useful to Bob as he continues to develop these. But these will be paced on the same process that we've had all along. So we started, 3 months ago with sites, and they were all over town, and then we looked at closer on those sites, and then we looked at other options for those sites, and then we put the building on those sites in a couple of different ways to ultimately decide these sites were better than those sites. Bob's going to apply the same process to this stage to ultimately arrive at one solution that says this is the grade configuration that we want. So he'll be studying both options over the course of the next month and a half. And he'll also be looking at options that put that program into the building. So you'll start to get a real sense of an overall concept for how what is a large number of classrooms can be arranged in different ways. And the more feedback that we can get from the committee as you're reviewing those, and the more feedback we get from the community and from the working group will help Bob to craft that as he moves through this process.
And I think we have to be really conscious of where those pull-up points are, right? So if we're looking at something, and I think your point is spot on in terms of what the community is going to be able to, you know, what do we need to either explain to the community more thoroughly, or what do we think is going to be a catch point? For example, I mean, Marathon had a lot of features you're talking about at the time. It's amazing to think about what's happened in the intervening years, but that didn't look like the school people were going to be used to. We probably had, Mike, 2 meetings dedicated to possibly turning that part in the front into a green roof where we could have gardens and all of these things. And it was a great concept, but at the end of the day, we didn't think we could sell. We didn't think the value of it was worth the sale to the community. We didn't think that was a place where the community was going to want to spend extra money. Yeah. So that's an example of what they're showing us here and what they will continue to show us. We get to do some of that. This probably isn't right for us. We don't feel like that this is, and we should be constantly talking to people in forums or just in general life to try to gather a lot of that feedback so that we can guide Perkins in that regard.
So piggybacking on that, as a member of the school committee, one of my concerns is, you know, what does the space look like for the principal who's going to be there and the teachers who are going to be there? I mean, I think yes, of course, the general public are the ones who are going to make the decision. But I know that there's also a lot of support in the general public for the teachers and the principals. So hearing from them, I think, like what their preferred design options are, how they can see themselves living in that space, I think would be really beneficial for a lot of us to go, okay, yes, that is a good option, because not only aesthetically does it appeal to me, who doesn't know a lot about how a school should run, but it appeals to the people who are going to have to work there, 8 hours a day or more. And they feel comfortable with that layout. I think it would be really good to have that feedback as well.
So I agree, and I mean, that's been part of the process the whole time, right? I mean, and it will continue to be. So like, this group didn't do much with the educational plan, right? There's not only Dr. Kavanaugh, Mrs. Carver, and Mr. Person, but there's an educational leadership committee, and we are having faculty forums, and we are. So I mean, I don't want to that is built into the process.
That's been a lot of moving pieces, but I think what I'm trying to say is sort of hearing publicly, here's what the teachers really like about this particular design, here's what our principal really likes about this particular design, like as an informational piece to the public would be really nice.
Do we have decision metrics, like what are the key criteria or the points we're going to hit while we compare all these options? And cost is also another.
So in previous meetings, that's been that there's sort of a template spreadsheet that has all of those factors that they'll be presenting further in January that does exactly that. It's a decision matrix for us, right? To say these are kind of where all these fit, and then it'll helps us make our decision. But that's definitely an output that we'll be getting.
Great.
Yeah, one thing I will say too about teacher participation in writing the educational plan, when we were going through that process, we would hand off sections of it to the directors of physical education, wellness, art, music, special education. So they've all had their hand in the writing of that, so that when they request some aspect, say for example the gymnasium, that's their request, not Mrs. Cower and my request.
Right.
I don't think we know enough about the gymnasium to make that choice.
Right, and I think I was trying to extract from that. So the plan is a document, and it's very kind of thick. So having lighter weight talking points about the teacher preferences and, you know, Mrs. Carver's preferences, and just having shorter, you know, I can put it on slides and talk about, you know, that kind of thing, I think is what I was getting to. Just the educational plan in itself is a very solid document to read. Just when we go in front of the public, right, here's what our teachers are saying, here's what our principals saying, here's, you know, how they look at these designs, so that it informs people as well.
And it feels like we're still a little bit a ways from there, right? So everything that has been hypothetically shared so far is in line with the dreams that we have. And I think that there's a short list of what people must have, and that includes bathrooms and heat and electricity, you know, places to plug things in. But there's really not a vast list of, here are all the things I must have moving forward. But, so I think everything that's been proposed so far is really nicely in line with our dreams for the space. And I think as we get closer to making some of the decisions, I imagine us saying, well, a long corridor with 30 classrooms doesn't feel just what we had in mind.
Exactly.
We think we would love to have some neighborhoods or some of the other wish lists on that we've had.
Yes, that's exactly what I'm talking about.
Absolutely.
And I feel like through the marathon project, the teachers were very involved with maybe like the FF&E portion of it, of what, you know, how they'd like to set up their classrooms. I think with Marathon School, we went with tables rather than traditional desks, and, you know, so I think teachers had an opportunity really at that, their tools that they're using, you know, to teach kids, so.
There's a lot of opportunities that peel off at all different points in the process for feedback from the educators. And the focus on the next couple of months is the main geometry of the building and the spatial relationships, and these three examples are part of that. And really trying to understand how it would lay out on the site, you know, that's the near-term goal. And then we would go to kind of the next step, which Bob showed, which is, okay, when you look at the classroom pods, what do those blocks look like? Now that could still morph and change and tweak, but we wouldn't be getting into the more detail, like where the windows go and light walls, and, you know, that comes later. So it's really the first couple of slides here that are the near-term decision points, and we'll still collect feedback from the teachers along the way before we get to the final schematic at the end of the summer, you know, before it goes to town meeting. And then there's still opportunities, like Tim noted, to do the layout of the individual classrooms and their nesting space as they make the classrooms their own.
Right.
Plus we go through our other partners, our other committees in town, design, review committee, planning board, you know, so we still have, you know, still a long road to hoe.
Correct.
I always found, and this is a little silly, but bear with me, I always found the Google Earth model works for explaining how design process works. You go to Google Earth, you type in a location. You're hundreds of thousands of miles in the air, so you can see the whole country. Then you click the zoom in function a little bit, and you get to the point, well, I can see who your neighbors are. And that's that first step in design. You want to understand it at that level. Yeah. The next step is you zoom in on the property and you understand the building. And you get that general sense of like, okay, well, you know, I can walk into this yard here, or I can walk into this building here. Maybe there's an entrance here, an entrance here. That's sort of the level we want to get to with, or maybe a little more than that, with the PSR, so that we understand the general layout of what the building that the town's going to have is. When we get to SD, then you're jumping into Google Street View. You know, what's it going to be like to stand next to that building, to understand what that building's going to look like. And so it's something that everybody has had the experience of trying to go to a place. Okay, I know to turn here and I know to get to that location. When I actually want to get there, what is it going to look like when I'm driving down the street? The process for feasibility is the same. We want to get to that street view and we'll get there. But right now, we're that step before, getting to the point that you understand where you're going to get to that layout of a building.
Right, and I feel like maybe I didn't explain myself well. So we're talking about how these designs don't look like school buildings that the town may be used to. And I feel like if we have teachers saying, oh, but this space, if we had that, we'd be able to do X, Y, Z. And we have that as part of the informational session for the town. It would help people understand how the layouts benefit the teachers and the staff. And that could ease some of that tension of why does the building look like this? Well, you know, here's how the educators are kind of imagining it from a high level still. Right, and here's why it could be a really good thing to have a building that looks this way.
So
Right.
what you're saying is having a voice, having educator voice will help non-educators understand why some of this unusual
Right,
stuff
exactly.
makes sense.
Exactly, and once again, there's a very positive, supportive feel for our educators within Hopkinton. So hearing the educator kind of imagining what it looks like to be in a building like that, I think it would be very beneficial.
Yeah, and that, so, yes, so
That's-
as you said,
that's
that's
all I was getting at.
absolutely gonna be a part of all of this, is that voice
Right.
of the educator in terms of why decisions were made and how it supports that overall education, without expecting people to read the full education plan document. Yes,
And that's
that
why
makes
the
sense.
MSBA expects the
Yeah.
education plan developed by the district gets interpreted by the designer and understands those relationships of all how the buildings and the components all work together.
Yeah.
And that'll be part of the next step.
So, are we good on options development
Yep.
at the moment? Okay. Do we have anything to talk about around meeting schedule?
No.
Other than the fact that this is the last time that we'll all be getting together in 2022?
Wow.
Next meeting is January 3rd.
Yeah, don't get too excited. We start right away. New Year's Day, then us. So yes. So the next public meeting of this group will be January 3rd, right here at HCAM. But we will have, and we'll send out more information about this, we will be having an appearance at the select board on the 20th to give a brief update. And then for the public and for this committee, be prepared for an action-packed January and February, where there will be many discussions at the school committee level about grade configuration and district-wide facilities, leading into discussions amongst this committee about selecting a final site and submitting that to the MSBA. So if there's nothing else.
I'm just gonna say one point. So
Yeah.
we've loaded Perkins has loaded on the website all the options that you've looked at to date. So
Great.
not just in meeting packet format, but we're starting to populate those tiles. So now we've loaded up the test bits, we're gonna load the PDP submission, and now the educational plan, and that's ready, that'll also go up there. And so we'll start to populate all those tiles so that we can, people can access it at their leisure.
Excellent. Thank
That's all
you,
we got.
everyone, for doing that. Okay.
Motion to adjourn.
So we have a motion to adjourn the meeting from Leah. Second by Shadul. All those in favor?
Aye.
Aye. Any opposed? Never opposed to adjourning the meeting. We are adjourned at 8:21. Thank you, and we will see everyone again on January 3rd, 2023.